Hi everyone, my name is Michael Isaac. I would like to welcome everyone for today's session. A little bit about who we are. Syntheria Group, founded late 2018, which is a Swedish company with focus on the next generation AI-powered products, data-driven ventures. Our idea is to combine deep technology expertise with business to transform state-of-the-art research in AI, computer vision, and data analytics. Our ecosystem includes a number of companies, specialized companies, Syntheria AI, Unibase, Semantic, Ring, Bmetrics International AB, Odin AI Technologies, Personas, and coming Parkira. We are proud to have a close collaboration with leading universities in Sweden, but also internationally, and industry partners. Our mission, of course, is to enable organizations to deploy AI with confidence, responsibility, efficiency at a scale. Syntheria bridges the gap between research and implementations, ensuring that every solution we build is ethical and transparent. And that's why we have today's session by Dr. Alexander Adamov. We are pleased to introduce him for today's speak, an international recognized expert in AI-driven cybersecurity with over 2 decades of experience. He frequently speaks at security conferences. Dr. Alexander is the founder and CEO of NeoGuard Security Lab and also a senior lecturer at BTH, Blekinge Institute of Technology. In his today talk, with the title LLM-powered threat modeling VC security testing, Dr. Alexander will demonstrate for us how LLMs, or large language models, can shift security verification earlier in the development lifecycle, analyzing the system's architecture, identifying weaknesses, and mapping attack path. So by that, I will welcome you, Dr. Alexander. You have the mic, so
Thank you, Michael, for the
thank you.
introduction. Yes, that's true. Cybersecurity and AI were my passion, have been my passion for almost 20 years, and now I am happy to see this revolution that happened with large language models. And of course, we tried to address these changes in our research. And I will present our research a little bit later. And today's talk will be devoted how we can leverage threat modeling that, of course, will be implemented with the help of large language model to identify potential and actual security issues before we start the security testing. And that's why the title of today's talk sounds a little bit more provocative, like LLM-powered threat modeling versus security testing. As Michael mentioned, I work as university lecturer at Blekinge Techniska Högskola. I also affiliated with my home university in Ukraine, Kharkiv National University of Radio Electronics, and I teach the courses such as malware analysis, reverse engineering, security and software development, and AI applications in cybersecurity. Let's start with the threat modeling concept. Why do we need to actually perform threat modeling? How does it help to make our product better? So on this slide, you can see how the design can be misused by the users. And from engineer's perspective, when we do design, we need to consider different cases, sometimes extreme cases, how users might use or misuse our product. Of course, the users can, or we can say adversaries can deliberately attack our product, and that's why we need to think about cybersecurity and security control, defensive mechanisms, how to make our software or even hardware secure and resilient against cyber attacks. So on these pictures, you can see that's different extreme cases of misuse of the cars or motorcycle that were designed by engineers, and I think nobody of these engineers have ever imagined that the products would be used in such a crazy way. A few words about the place of threat modeling in software development lifecycle. So I usually in my lectures I refer to Microsoft Security Development Lifecycle, SDL. Here you can see the diagram that represents different stages of software development lifecycle, starting from training, requirements, design, and so on. And threat modeling is actually part of is conducted at the design stage. Well, that's how it should be. That's how it should be in theory, but in real life, in my practice, I see that the organizations come to security audit just before the release at the verification stage. And when security issues are discovered and they require, for example, changes in design, then we need to, jump back into the design stage, redesign the whole architecture or part of the product, and again start implementation, testing, and so on. So this takes time, and that's why it is essential to start threat modeling as early as possible at the design stage. And that's one of the advantages of threat modeling in comparison to security testing or verification. So we can start analyzing the threats and providing mitigations for them early at the design stage. There is, as for the history of threat modeling, it was firstly invented and proposed by Microsoft internally in 1991. But later, Microsoft started promoting this concept in IT industry, and many companies joined this initiative, such as Oracle, Cisco, and many others. In 2007, they released the tool. It's called Microsoft Threat Modeling Tool. Before that, engineers, they used to play what is called security poker, just a deck of cards where engineers just pick the cards, read the description of the threat on the card, and then if decide if it's relevant to the project, to the product, then they need to come up with the mitigation. And then it goes round among engineers, and every engineer takes this card and justify this threat and provides mitigations. But of course, nowadays, we need a solution that would be more efficient and helps to identify threats in a more consistent and faster way. There are books also. There is a book from Adam Shostak. He was security architect and engineer in Microsoft, and he was actually the father. He's the father of threat modeling, and he published the book in 2008. There is also a framework or methodology available from Avasp SAM. So those who are familiar with security testing, web application security testing, those should know about Avasp. SAM is a software assurance maturity model. So it's pretty much the same as Microsoft SDL. It has also like different stages of software development lifecycle, such as governance, design, implementation, verification, operation. They name it in a little bit different way than Microsoft. But again, at the design stage, we have this threat assessment practice, which includes threat modeling and application risk profile. So again, threat modeling practice is used to identify potential security threats for the given architectures at the early stage, at the design stage. So we have a chance and time to come up with the mitigations and introduce these mitigations into design, into implementation, and create specific security tests cases. So why Microsoft Threat Modeling tool or the tool from Avast, which is called Avast Threat Dragon or Security Poker, are not enough and are not a good solution as for now? Because first problem we have now is a lack of security experts. So typically the engineering team, they should have like one cybersecurity expert that who can guide this threat modeling process and help engineers to identify potential security threats and come up with the mitigations. But in fact, we have the statistics from Gartner where we have like a one security engineer against 100 software engineers. That's why we need something like a tool methodology or maybe AI agent that would replace a security expert and will be available for software engineering teams. Another problem is growing number of threats and attacks. On the right, you can see there's an exponential growth of CVEs, it's vulnerabilities, registered vulnerabilities, and of course, the more software products we have right now, the more vulnerabilities can be discovered, and the bigger software become, the more threat landscape and attack surface we have. That complicates this challenge even more. Inconsistent results. So often teams that do threat modeling, they have different level of expertise. One team has a better security expertise, another team has another like a lower level of security. Then they both teams, they do threat modeling and come up with a threat modeling report identifying potential threats for the software. But the quality of these reports are different, is different for both reports. So that's the problem, how to make standardize the quality for this threat modeling reports. Again, we need to come up with the methodology, we need to use tools, and we need to have some quality metrics that are essential to guarantee this quality gate for our threat modeling process. Again, sometimes the project is so big, so it's really hard to find the ground truth, the information about how the actual software works, and we need to collect like big teams, like more than 10 people to threat modeling meeting, and it's of course not always possible. And the last problem is a lack of domain-specific knowledge. For example, when I was when I'm invited as a security consultant to do security audit of the product, sometimes it's hard for me to get into the specific industrial domain. So it was like 1 month we do threat modeling for medical device, another month we do threat modeling for automotive industry and milk tech and many others. And all of them, they have their own set of threats, threat landscape, and their own compliance requirements, like how the risk assessment should be performed, what the risk analysis matrix should look like, and so on. So this also requires like this multi-domain skills, which is not always possible to have for a single person. What's going on from other side, from attackers, from adversary side? So what kind of threats we face right now? And of course, AI and specifically generative AI are misused by criminals and by nation state actors, threat actors. For example, on this screen, you can see the one of the latest backdoor developed by Russian military intelligence service group called Fancy Bear. The malware is called LameHack, and inside of the malware, you can see like two LLM queries, prompts. One prompt says like make a list of commands to create folder info and gather computer information, hardware information, process and service information, network information, Active Directory domain information, execute in one line, and add each result to text file. So this is a basic prompt to generate script to perform reconnaissance on the target machine. There is also, and yeah, there is a mention of the model. It's a Qwen 2.5 coder, 32 billion token. And the model, if you can see a little bit over this, I don't know if I can zoom. No, I cannot zoom. It's hosted on Hugging Face. So basically, the attackers, they use LLM hosted on Hugging Face, and they can execute prompts just in time, what is called just in time, which means they do not need to carry this code in the backdoor in the Trojan program, but rather than this code will be generated on the fly, just in time execution, using this LLM hosted on external service. Second prompt asks to make a list of commands to copy recursively different Office and PDF TXT documents in user documents, downloads, desktop folders to a folder info. To execute in one line, return only command without markdown. Temperature 0.1 and other configurations. So AI, we can see that AI is used as a weapon nowadays. But that not happened right now. So the attackers, specifically nation-state groups, they started using these LLMs starting 2023, just after the appearance of ChatGPT. But even before, for example, for one of the customer, we did research where we created ransomware agent empowered with the artificial intelligence. So on the screen, you can see this simulator, ransomware simulator. This is a tool that encrypts files as a target folder. You can configure it, provide some properties, algorithms, crypto library, extensions that will be replaced, that will replace the original extension, and then you execute. And then we also started behavior-based antivirus that detects this activity, because the majority of modern antiviruses, they have this behavior-based protection. They analyze the sequences of events, and if they see like a suspicious sequence of events, for example, changing the data in the files or encrypting the data, then they can just block this activity, terminate the process, and protects the user against further encryption. So this is what we did 5 years ago, and we decided to make this ransomware agent more intelligent, and we used reinforcement learning to train the agent to encrypt files in such a way so it can bypass antivirus defense. And it took just 600 iterations to bypass antivirus agent. So the idea of training was just to identify like different set of configurations, the amount of files that are encrypted at once, and then just some delays are introduced between these iterations, just to trick behavior-based protection from antiviruses. So AI as a weapon, but AI can be also a target for attackers. AI as a target. The such term as adversarial machine learning is well known for probably a decade, and again, Microsoft was the one that initiated the project, the framework, the development of the framework called MITRE Atlas. Atlas is the abbreviation. I can actually show you. So MITRE Atlas. This is the matrix of tactics and techniques used by attackers to attack AI and LLM-based software. So Microsoft was the one who actually initiated this process, and so here you can see like all different techniques at different stages of the attack that are used by attackers, that can be used by the attackers to compromise AI based software. So there are, as I said, there are different techniques how attackers can attack AIs. For example, training data poisoning, jailbreaking. For LLM, it's prompt injection. Of course, it's a number one by popularity, the types of the attack. And all this require from defense side, from again from threat modeling perspective, development of new mechanism how to take all these techniques, all these attacks into account when we developed our software. And of course, to cope with this threat, adversarial attacks against AI or AI-powered attacks, we can also employ AI in cyber defense. This is how we can, find the balance, equilibrium between the offensive and the defensive side. And so here we come to our research project, which is called Tremolia, and we developed a tool that automates the threat modeling with the help of large language model. So far, we use OpenAI, but it's possible to connect to any LLM. And this helps to first to automate this process, so you don't need to spend like hours just trying to enumerate all possible threats for your software, but it can be done by the tool with the help of large language model. But you can also introduce different contexts and different threat frameworks. So, for example, if you need like a classical threat modeling, you can use just Stride framework, which introduces 6 classes of threats: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. This was again designed by Microsoft many years ago. But if you have AI in your software, then you need to think about frameworks that consider AI threats, such as MITRE Atlas, Avasp ML Security Top 10, Avasp LLM Top 10. So this introduces common attacks and common techniques used by adversaries. The project is financed by Vinova and co-financed by Vinova, and BTH and Ericsson are participants also. So here is our team at BTH that works on this project. Me, Davide Fucci, who is on the call, and Felix Jedrzejewski, our PhD student. The idea of the tool that we can take into the account, take into consideration different information about this software project, such as high-level architecture, data flow diagrams, requirements, documentation, code base and infra data. Then everything is submitted to our tool, and LLM process all this data, structure in the proper way, and then applies threat frameworks stored in our RAG database, retrieval augmented generation. This is how we enrich standards-based LLMs, such as ChatGPT, with a specific knowledge of threats available in these threat frameworks, such as MITRE Atlas or MITRE ATT&CK or Avast Top 10. And finally, we get the report with potential threats, risk score, mitigations, and of course, what is important is the quality metrics. Quality is the key for our project because when we start using LLMs, AI, then how can we make sure that the report generated has no hallucinations, or maybe the whole report is like one big hallucination. And that's why we started our research that has been in progress for more than 1 year, trying to find out, okay, what would be the quality metrics, how we can check the quality of the generated report. And we came up with like set of these metrics, like a coverage for threat framework matrices, accuracy, precision metrics, and so on. That helps to identify the quality. Moreover, we conducted a survey where we interviewed engineers from different EU companies regarding what metrics are important for threat modeling for security audit. And we also process this information and trying to extract a useful feature for our tool. So this is basically how it works. The main component is, of course, it's LLM. It's kind of our engine, so we can connect any LLM to our tool. Then the knowledge base is stored in our RAG database. And the guardrail, this validation checks, they are implemented as for input data and for output data as well. So basically, these three components: LLM, RAG, and guardrails, pretty much like a standard architecture. For specifically for Ericsson, we designed AI agent. We implemented as a MCP server, so it can be run for Ericsson engineers as AI agent. And I think it's time to show you a little demo. So basically, I'm going to show this web UI version. So here, the first step, you can upload any documentation you have, like requirements, project description, whatever you have. Then second is you can load the data flow diagram or high-level architecture of your project. Data flow diagram is better because it also points all these like trust zones and the data flows that are essential for threat modeling process. Then, because we use multimodal LLM, we translate the picture into textual description, identify types of the elements that are essential for threat modeling, and you can change it if you find the mistakes, but usually it works fine. And then basically you can start modeling. It takes around like 1-2 minutes to generate the report and to validate them, trying to find some mistakes, for example, some semantic inconsistencies in generated threads when this thread description does not relate to the category identified. Also, we identify, okay, how many threads from thread frameworks were generated. This is called coverage, threat matrix coverage, and a bunch of other metrics that we consider important to verify the quality. So as I said, the first part is report generation. Second part, it's validated, and now we can see it. Basically, it's just a table where we have element or data flow, the description of the attack, type of this threat, if it's how it maps to Stride or Avast top 10 framework. Then we can suggest mitigation. So how to fix if this threat is relevant, if this vulnerability or weakness or exposure is available in our product, in our infrastructure, then we can propose mitigation. And risk score, we use CVSS just to be able to prioritize. As you can see, it's some hallucinations. I would say that sometimes score is missing or the risk score vector is incorrect. So we need to fix this. All the so here we have our validation part, different metrics. I'm not going to explain every, but here we have some hallucinations, mistakes that can be fixed. The coverage, we can see that we have like a really low coverage from the first shot. And basically I can select, let's improve stride coverage and fix logical mistakes, and click extend the report. Yeah, sometimes let's I will try to just load already available report that we have, just to not to restart. And extending the report, we can improve the coverage. As you can see, like more threads were generated. We can see the coverage for different frameworks, like privacy frameworks, Avast to 10, depending on which framework you need to take into account during this threat modeling process. And you can select which threat framework you want to use in your case. So for example, if you don't need ML, then we can just basically remove whatever is related to ML or AI threats. If you don't need, for example, privacy threats, you can remove also Lindu. So this is how it works. Let me go back to the presentation. Then the important part is evaluation. This is the final part of the presentation. So we generated the threat modeling report, but how can we make sure that it can find actual security issues, actual vulnerabilities? To do that, we decided to test our tool on so-called vulnerable applications. This is applications that are used to train ethical hackers. They're applications with already known vulnerabilities. And students, for example, they need to find these vulnerabilities by doing this penetration testing or security testing, whatever we call. And then we just took Azure Goat application, vulnerable application, and we do threat modeling with a Microsoft tool and with our tool. And with our tool, we managed to identify all classes of threats that relate to actual vulnerabilities available in these applications. It's 100% coverage for the vulnerabilities available in Azure Goat. And Microsoft only identified 57 classes of threats. Same we did with another application called Vulnerable Bank. And here we didn't get actually 100%, but the interesting thing that if you provide more information about the application, like a documentation or like requirements or source code, then you can increase the percentage of discovered security issues in the applications. Then we, for example, we did like a zero shot. We got, I have some numbers here, like 73%. Then we run first shot. We introduced some documentation, project description. We get 85. Then we added even more information. Then it's the percentage of discovered vulnerabilities decreased for some reason. But the good thing is because it's always probabilistic and the generated report is never the same, we can just merge the discovered threats from first shot and second shot, and this merged report will have even better accuracy from perspective of identified threats. And Microsoft couldn't identify could identify only 55% of actual vulnerabilities. And the tricky part here is AI part. So the vulnerable bank application uses AI chatbot. And Microsoft tool and Avast Dragon tool, they are kind of conventional tools. They do not have AI libraries and they do not do a modeling for AI threats. So now our product is validated by Ericsson. We will deploy it soon and may make it available for Ericsson engineers. So far, we published 2 papers and more coming. And yeah, that's it for this presentation. To sum up, the idea is to start the process of identifying potential threats early in the software development lifecycle. And if we can identify the threats at the design stage, so we would leave less work to security testers at the verification stage. And of course, we can save time. We don't need to redesign or rewrite the code to fix this vulnerability because we have this. This will become like a part of our normal development process. So thank you. And if you have any questions.
So thank you, Alexander. Very nice to hear that we have everything under control, I suppose. Yes, so I would like to invite just Davide to present a little bit about him and the project because you had a slide about it also. And then after that, we will open for questions. So anyone remote would like to ask a question, just raise your hand as you do, and we will just let you to, yeah, say your name and you can ask your questions. Yes, please, Davide.
Yeah, I just wanted to thank Alexander for the talk and quickly introduce myself. My name is Davide. Probably you see my name already on Alex's presentation. Together, we are working on this exciting project called Tremolia, which is focusing on the aspect that Alex mentioned, so strictly threat modeling. And I would like to mention quickly for the audience another project we're working on, also in the area of security, which is called SISAM. One slide, so you can have most of the information there. And this project actually, it's a sister project of Tremolia, where we look at how can we support developers integrating security through intelligent tool support. And this is a project in collaboration with Syntheta. So we are looking at the tooling that Syntheta develops and improve them, let's say, from a security perspective, using, among others, also large language models. So if you want to know more about the project, the SESAM project, if you want to know more about also tools that we are developing for this project, please have a look at the webpage that you can find here, sesamproject.github.io. And I guess that's all I wanted to say. So I leave the stage for asking questions about Alex's presentation.
Thank you, Davide.
Oh,
Yes, we are of course proud to say that we are part of that project, that research CISAM and also others. Yes, Alexander, I have at least one question or several, but I will start with one. Uh, so you mentioned the role lack of security experts because you mentioned you have 100 developers against this poor guy, one person, or 50% of his time he's just
Mhm.
trying to get the admin, as we do here at Cintera Group, to work with it. So this is the reality, honestly. But adding more tools, would that solve, I mean, the main issue, or what do you think? I mean, should we maybe educate everyone that is doing development, or should we educate everyone? The security is a vulnerability that a company have, whatever you work with. Yes, please.
Yeah, I think it's essential to educate people and software engineers because still the threat modeling process and I believe the other security practices, they cannot be, even security testing, they cannot be fully automated. So still there is a need for human presence in the loop, and which is like compliance requirements from one side, but from other side it's common sense because you need to be able to verify the results of generated by AI. And AI sometimes has no like all details, all the context, what is not all details of the project are documented, for example. And some of the knowledge they are just shared through conversation between engineers, and that's why it is essential to have engineers on board. But again, it is essential also for engineers to understand, okay, why it is important for them to do this threat modeling and to care about cybersecurity and what kind of threats exist in for the product and how they can identify the threats and how they can mitigate the threats. And all this, of course, requires like education. That's why in Microsoft, in Microsoft's security development lifecycle, they have this stage number one that goes before requirements. It's a training. So in a good way, when we, for example, start the project, we need to train engineers. It can be, of course, training related to cybersecurity, but it can also be something relevant to the domain, specific domain. If it's, for example, outsourcing team, that this team should be introduced to some domain-specific knowledge, of course. So human will still remain the key part of the process, but the tools would help to automate all these tedious tasks, and the trend of automating these processes is not new. As I said, the first tool, Microsoft tool, was published in 2007. So this trend is available in the industry, but now with LLM, I think it can do even better.
Yeah. Any questions from the audience? Otherwise, I will go for another question. Okay. So one important thing, Alexander, and as you know, today everyone is talking AI will replace the human or the people and the human capacity, which is annoying, honestly, for those who knows about machine learnings and AI, that this is not really the truth. The most now valuate a company in Sweden saying that we will replace everyone, and you don't need to be a software developer. You can just go in and do your thing. Honestly, I mean, do they even know what security vulnerability is? When we talk about, okay, you have lacks in security, and you need to check your things. I mean, nowadays everyone is just, as my son is doing, go in and just say, oh, give me something. Yeah, give me a homepage. Oh, very good. Yes, this is really nice. But they are not really into this next thing, which is the security, which is really a big risk, a big, huge risk. And I would like to have your view, and also David, regarding, I mean, how should we think? I mean, how should we do it? I mean, these people are earning a lot of money and saying that you don't need developers anymore. And we are saying, no, 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 please take it easy. It's not the truth. You have more than just people writing. Yeah, please.
Maybe I can share one quote that I like particularly from one of the lead AI researcher at Microsoft, working on LLM for code. And basically what they say is that you should treat those code assistants as interns, right? So they know what they're doing. They are very eager to do things. They do things quickly, but they're still interns. So you need to constantly check on them
Exactly.
because, they just started working. They're just at the beginning, right? So we are definitely not at the level that LLM will push away work from developers, especially senior developers, so developers that need to check on those interns. But on the other hand, to become senior, first you have to go through all the junior steps and
Of course.
being an intern yourself. So I don't think this is something that will happen anytime soon, at least.
Thank you. Alexander, any comments?
Yeah, I completely agree with David that it should be considered just as a tool. So it's not going to be like a full replacement of the engineers. So I do not see any threat or problem for engineers. But rather than just you get this one more nice tool or the set of tools that you can use in a very convenient way, and introducing this AI agent and agentic architecture, I think it's really something cool when you can communicate not with with one LLM or AI model, but rather than just with some consortium of LLM
Exactly.
models. Yeah, so that's fascinating, and I'm looking forward to how this will help us to improve our software development process.
So the last question is, Alexander. So we have the EU Act, AI Act, which is a regulation that we have in Europe, mostly used, and is now coming into 2026, coming out really strong to companies. I mean, how it is used. The AI should not be a black box. There is a truth and there is also a reality, but there is also something that you really don't see it. A lot of people are using the LLMs, even though we are saying that they are not doing it. But one main part in that is the risk assessment that you have, which is you are doing with your tool. I think, how do you see that as a complement to this kind of regulation and how can you build on that? Because I think this is a strong case, especially for companies, I mean, who need to act according to regulations that we have now coming out with a really good big fine if they don't follow it, especially I mean, institutions, which is government owned institutions. Yes, what's your view on that? You and also Davide, please jump in.
Yeah, I would start. That's actually this EU AI Act and this regulations related to establishing trustworthy and reliable AI in the
Mm.
organizations.
Yes.
This actually was the main driver of the project
Yeah.
because so how to guarantee that the AI that you use is safe and secure to use?
Mm.
So we have some requirements for AI, and as I said, AI may be considered as a threat, or AI can be misused by the users. So the AI can be attacked, or AI can be used as a tool, as a weapon. And to understand this threat and all these implications of using AI in your software, we came up with the threat modeling that takes into account not only like general security threats, like information disclosure, encrypted protocols, lack of authentication authorization, but also threats related to the AI usage. And we relied on already available threat frameworks and libraries developed by such organizations as Microsoft and a bunch of others, Avast, Microsoft, Mitre.
Mm.
So we leverage this knowledge collected by the industry, and we automate this knowledge, the consumption of this knowledge, and integrate it into that modeling process. So engineers do not need to be educated in a specific set of AI threats, but rather than just they have this list and then they can decide, okay, if it's relevant or not. Davide?
Yeah, and I mean, to put another angle to that, which I feel is something that the AI Act doesn't really cover, is how easy or how auditable are those models. So for example, things like OpenAI GPT 5.1 is just a black box. We don't have any information about what's going on there. Fortunately, in Europe, we have also, let's say, better cases of companies that, of course, on one hand, they need to make money by selling those models. On the other hand,
Mm,
they make them accessible for auditing. For example, Mistral out of France, so a European company, just last week released maybe not a frontier model, but a very good model that can be used, for example, for coding, and did so with open weights. So at least, if you wanna, especially for researcher, if you wanna go and look at the different gears and buttons and lever that are pushed when something happens in this model, you can actually go and do so and made it more auditable than things like, yeah, GPT or Anthropic or let's say more frontier models that coincidentally are not European.
of course, yeah. Yes, I have a lot more questions, but we'll stop there. So, to wrap up, thank you very much, Alexander, for this nice presentation. And yeah, Daniel is writing, thank you for a great, interesting presentation, of course. And also, Davide, thank you.
Thank you.
As a Synthera Group, we have invested in also a company called Odin AI Technology, which is really looking into this EU AI Act. And we have started with computer vision part, I mean, sending in images and seeing the risk of that using different data. And our hope is maybe for the next session to invite Payman, which is also a assistant professor at Halmstad University. And maybe that can be also a collaboration with this project, of course. Please feel free to send any questions or thoughts that you have. Then I thank you, everyone. Thanks.
Thank
Thank
you.
you.
Fantastic.
Bye
Thank you so
bye.
much. Have a great day, everybody. Bye.